What if you could drive a car for over 1,000,000 miles without a single major repair? Sounds impossible, right? Yet some vehicles, from classic sports cars to rugged SUVs, have done exactly that. These aren't museum pieces or carefully babied classics. We're talking about daily drivers engineered to last decades. In the next few minutes, we'll reveal the exact models that consistently hit million-mile milestones, why they endure where modern cars often fail, and the maintenance secrets that keep them running forever. Buckle up. This is the ultimate guide to automotive immortals. 1. Volvo P1800. Legendary longevity. The Volvo P1800 is widely regarded as one of the most durable sports cars ever produced, with documented cases of vehicles exceeding 3 million miles without major mechanical failure. This was not limited to engines. The transmission, differential, and suspension components remained original even after decades of regular use. What sets the P1800 apart is the combination of engineering philosophy and build quality from its production era. The engine, originally a B18, later upgraded to B20, featured exceptionally thick cylinder walls, a forged steel crankshaft, and precise tolerances far exceeding modern standards. Every component was tested for durability, often running engines at maximum RPMs for extended periods to simulate extreme wear conditions. The result was an engine capable of decades of daily driving, surviving harsh winters, extreme heat, and constant city and highway use without significant wear. Maintenance, though methodical, was straightforward and predictable. Scheduled oil changes were adhered to rigorously, valve clearances adjusted periodically, and timing components replaced according to preventive schedules rather than as a reaction to failure. Over millions of miles, engine wear remained minimal, bearings stayed within factory specifications, and cylinder cross-hatching persisted, illustrating the over-engineered durability that modern vehicles rarely achieve. Beyond the engine, the P1800's suspension, transmission, and drivetrain components were built to withstand stress far beyond typical usage. Materials were robust, and design simplicity reduced failure points. These vehicles were also designed before the era of planned obsolescence, meaning longevity was an inherent goal rather than a marketing claim. In essence, the Volvo P1800 exemplifies how overbuilt engineering, simple systems, and preventive maintenance can produce a sports car capable of reaching multi-million-mile milestones, setting a benchmark that even modern vehicles struggle to achieve. For enthusiasts or buyers seeking longevity, understanding the P1800's design principles offers a roadmap for identifying cars with similar potential today. 2. Mercedes-Benz 240D. Diesel durability at its finest. The Mercedes-Benz 240D, particularly the OM616 diesel models from the 1970s and 1980s, is a textbook example of engineering designed for extreme longevity. These vehicles have documented cases exceeding 1.2 million miles without any major engine, transmission, or differential rebuilds. Unlike many modern vehicles, the 240D was engineered with simplicity, overbuilt components, and durability in mind, making it a favorite among high-mileage users worldwide. The OM616 diesel engine is a naturally aspirated inline-4 diesel, renowned for its thick cylinder walls, forged crankshaft, and robust bearing design. Cylinder wear over hundreds of thousands of miles is minimal, and engine tolerances were intentionally tight, providing consistent compression and long-term reliability. The manual transmission paired with this engine is equally durable, designed for decades of daily use without internal failures. The drivetrain was built for efficiency and endurance rather than outright performance, contributing to its extraordinary lifespan. Routine maintenance for these vehicles was simple, yet highly effective. Oil changes at 3,000 to 5,000 miles, fuel filter replacements at 6,000 to 10,000 miles, and regular air filter maintenance kept the engine running at peak efficiency. Even after over 1,000,000 miles, many components showed minimal wear due to this combination of engineered durability and disciplined preventive care. Beyond the engine, the 240D's body, suspension, and interior components were built with longevity in mind. Suspension arms and bushings were made from robust steel and high-quality rubber, capable of handling extreme loads and rough roads. Door handles, window cranks, and other mechanical systems remained functional for decades without replacement. The simplicity of the electrical system, minimal electronics compared to modern vehicles, reduced potential failure points dramatically. The Mercedes-Benz 240D demonstrates that engineered simplicity, robust materials, and predictable maintenance intervals are crucial to producing producing vehicles capable of million-mile reliability. For anyone studying automotive longevity, the 240D provides clear lessons in how durable engineering and preventive maintenance combine to create true automotive immortals. 3. Toyota Land Cruiser, built for endless endurance. The Toyota Land Cruiser, particularly models from the 1980s and 1990s with the 1FZ engine, has earned a legendary reputation for extreme longevity. Multiple documented examples have surpassed 1 million miles with original engines, transmissions, and drivetrain components still intact. Unlike many SUVs built for comfort or city use, the Land Cruiser was engineered for rugged global conditions, from desert heat to Arctic cold, ensuring reliability in the harshest environments. The 1FZ inline 6 engine is overbuilt by modern standards, featuring exceptionally thick cylinder walls, robust head gaskets, and oversized oil passages to maintain lubrication under extreme stress. The engine design allows it to operate under heavy loads, high towing requirements, and long duration off-road use without major wear. Cylinder compression remains consistent, and timing components are durable enough to exceed 900,000 miles between preventive replacements. The Land Cruiser's chassis and suspension systems are similarly robust. Frames are reinforced for high-stress conditions, suspension arms are built from thick steel, and components are designed to minimize flex and fatigue. This engineering approach reduces mechanical failures even under decades of daily driving or in remote locations where maintenance opportunities are limited. Routine maintenance is straightforward but critical for longevity. Oil changes every 5,000 miles, timing belt inspections around 990,000 miles, and preventive servicing of fluids and filters have been documented as the key factors in keeping these vehicles running. Notably, Land Cruisers that exceed 1 million miles typically share one characteristic: their maintenance is predictable, consistent, and strictly followed, demonstrating that robust engineering paired with disciplined care creates vehicles capable of true automotive immortality. Additionally, Land Cruisers feature mechanically simple yet effective systems, such as non-complex electronics and straightforward drivetrains, reducing failure points that plague modern SUVs. These vehicles are proof that when engineering prioritizes durability over cost-cutting or styling trends, the result is an SUV that can operate reliably for decades, covering millions of miles without major mechanical intervention. 4. Lexus LS400. Luxury meets unmatched durability. The Lexus LS400 is a rare example of a luxury sedan engineered to endure 1 million miles or more with original mechanical components. Unlike many high-end vehicles of its era, which traded longevity for refinement or complexity, the LS400's engineering prioritized reliability across every system, from the engine to electronics, making it one of the most durable luxury sedans ever produced. At the heart of the LS400 is the 1UZFE V8 engine, designed with exceptionally tight tolerances and robust materials. Every engine was assembled in a near cleanroom environment to ensure precision, with components like the forged crankshaft, oversized oil passages, and advanced cooling systems built to handle extreme loads, towing, and prolonged high-speed driving. Even after 1 million miles, these engines consistently show minimal wear, retaining factory-spec compression and oil pressure. The transmission and drivetrain match this philosophy. The automatic transmission is smooth shifting and highly durable, requiring minimal intervention even under strenuous conditions. Suspension components, steering systems, and other mechanical elements were engineered to maintain factory-level performance for hundreds of thousands of miles. This over-engineering extends beyond mechanics. The interior materials, trim, and electronics were also selected for longevity, with leather, wood, and controls designed to remain functional and visually intact over decades. Maintenance for the LS400, while not excessive, is consistent and preventive. Regular oil changes every 5,000 miles, timing belt servicing around 990,000 miles, and periodic transmission fluid replacement ensures that every system continues performing at peak levels. This disciplined approach, combined with robust original engineering, is why these sedans can achieve milestones that modern luxury vehicles rarely reach. The LS400 demonstrates that luxury and longevity are not mutually exclusive. By engineering every component to the same high standard, Toyota created a flagship sedan capable of lasting longer than most vehicles in its class, delivering consistent performance, comfort, and reliability well past the 1 million mile mark. For anyone seeking a luxury car with true endurance, the LS400 sets the benchmark for what is possible when precision engineering meets preventive maintenance. 5. Engineering philosophy behind million-mile vehicles. The extraordinary longevity of vehicles like the Volvo P1800, Mercedes 240D, Toyota Land Cruiser, and Lexus LS400 is not accidental. It's rooted in a distinct engineering philosophy from the 1960s through the early 1990s. During this era, manufacturers prioritized over-engineering, durability, and simplicity over cost-cutting or planned obsolescence. Components were designed to last indefinitely rather than to meet a minimal lifespan target typical of modern vehicles. One striking example is the tolerances used in engine components. In the 1980s, engine cylinders, crankshafts, and connecting rods were manufactured to twice the precision and robustness of many modern vehicles. Cylinder walls were thicker, bearing surfaces more robust, and materials selected for high thermal and mechanical resilience. This meant engines could survive prolonged high-stress conditions, extreme temperatures, and continuous daily driving for decades. Simplicity was also a critical factor. Vehicles from this period typically had fewer parts, sometimes half the number found in today's cars, reducing the number of potential failure points. Fewer electronics and less complicated systems translated to greater reliability and easier maintenance, ensuring that drivers could perform routine service without specialized tools or computer diagnostics. Quality control standards were another differentiator. In older manufacturing plants, parts that deviated even slightly from specifications were rejected. Modern factories often allow a wider margin of variation, prioritizing speed and cost efficiency over long-term durability. Additionally, the mindset of engineers during this period emphasized building vehicles that could handle triple the expected stress load without failure. Materials, welding techniques, and assembly methods were all selected with longevity as the ultimate goal. Ultimately, these design principles, over-engineering, simplicity, precise manufacturing tolerances, and preventive maintenance-friendly layouts, created vehicles capable of exceeding 1 million miles. Modern manufacturers rarely replicate these practices due to market pressures, cost constraints, and consumer expectations, which makes these million-mile vehicles truly unique benchmarks in automotive history. 6. Common traits and maintenance secrets of million-mile vehicles. After analyzing hundreds of high-mileage vehicles and documented cases of cars exceeding 1 million miles, a clear pattern emerges. Despite differences in brand, type, or era, these vehicles share a handful of critical traits that directly contribute to their extraordinary longevity. Understanding these traits can help guide buyers and enthusiasts toward vehicles with similar million-mile potential. First, the engineering philosophy is consistent across all million-mile vehicles. Engines, transmissions, and suspensions are overbuilt, with thicker cylinder walls, reinforced frames, and durable drivetrain components. Precision tolerances ensure minimal wear over time, while simpler mechanical systems reduce points of failure. Fewer moving parts and straightforward electronics mean these vehicles can survive decades without major intervention. Second, maintenance accessibility plays a key role. Vehicles like the Toyota Land Cruiser and Lexus LS400 were designed so that routine servicing, oil changes, filter replacements, timing belt inspections can be performed efficiently. Components that require frequent maintenance are easy to reach, avoiding unnecessary labor that can discourage regular care. This accessibility directly impacts the vehicle's lifespan. Third, preventive maintenance discipline is universal. Million-mile vehicles were serviced proactively, not reactively. Oil was changed at regular intervals, timing components replaced on schedule, and fluid levels monitored consistently. This approach limits wear before it becomes catastrophic, allowing engines and drivetrains to last far longer than typical vehicles. Finally, material selection and simplicity matter. High-quality metals, robust suspension components, and mechanically simple systems increase durability. These cars also existed before complex computer controls became standard. Fewer modules, sensors, and electronic dependencies mean fewer failures over time, creating a reliability envelope that modern vehicles rarely match. In summary, the combination of over-engineered components, accessible maintenance, preventive care, and mechanical simplicity defines the blueprint for million-mile vehicles. These traits are a roadmap for anyone seeking long-lasting cars today, showing that longevity is achieved not by luck, but by intentional design and disciplined care. 7. Modern vehicles with million-mile potential. While vehicles from the 1960s through the 1990s set the benchmark for longevity, several modern cars have been designed with the same principles, showing potential to surpass 1 million miles with proper maintenance. Identifying these vehicles requires understanding overbuilt engineering, proven powertrains, and simple yet robust designs. First, the Toyota Tundra, especially models with the 5.7-liter V8, is a standout. This engine has remained largely unchanged for over 15 years, demonstrating proven durability durability, units with over 400,000 miles retain strong compression, consistent oil pressure, and smooth shifting transmissions. The V8's design emphasizes oversized components, reinforced cylinder walls, and simple mechanical systems, making it a candidate for extreme longevity. Second, the Lexus GX460 continues Toyota's legacy of building SUVs that can endure decades of driving. With a 4.6-liter V8 derived from the Land Cruiser platform, the GX460 features robust suspension geometry, durable drivetrain components, and relatively simple electronics. Documented cases show these SUVs surpassing 300,000 miles with zero major failures, suggesting they could reach million-mile status with disciplined preventive maintenance. Third, the Porsche 911 naturally aspirated flat 6 demonstrates that performance and longevity are not mutually exclusive. Models with naturally aspirated engines, minimal turbocharging, and conservative power outputs can exceed 600,000 miles on original components. The flat 6 engine is mechanically simple, with excellent cooling, robust materials, and a design philosophy that prioritizes reliability alongside high performance. The key to achieving million-mile success in modern cars is not just selecting the right model, but adhering to preventive maintenance schedules. Oil changes, fluid checks, timing component inspections, and filter replacements must be performed proactively. Following manufacturer guidelines and choosing vehicles with overbuilt, simple mechanical architectures greatly increases the likelihood of reaching extreme mileage milestones. For enthusiasts aiming for longevity, these modern vehicles show that while the automotive landscape has changed, the principles that created million-mile legends still apply. Robust engineering, proven design, and disciplined maintenance remain the path to automotive immortality. 8. Building the next generation of million-mile vehicles. Understanding what makes a vehicle capable of exceeding 1 million miles is more than just automotive trivia. It's a blueprint for choosing, maintaining, and preserving cars that can last decades. From the Volvo P1800 to the Toyota Land Cruiser and Lexus LS400, the common factors are clear: overbuilt engines, simple mechanical systems, durable materials, and disciplined preventive maintenance. Modern vehicles with similar DNA, like the Toyota Tundra, Lexus GX460, and naturally aspirated Porsche 911 show that this legacy of longevity isn't lost, it's just rarer. The practical takeaway is simple: when shopping for a long-lasting car, focus on engineering honesty. Look for vehicles with proven powertrains, fewer unnecessary electronic modules, and mechanical simplicity. Check the manufacturer's maintenance recommendations and plan to adhere strictly to preventive schedules. Vehicles built this way are not just surviving, they are thriving well past the milestones modern cars are expected to reach. Equally important is data-driven maintenance planning. Changing oils, fluids, and filters at recommended intervals, performing timing belt inspections, and monitoring critical drivetrain components are inexpensive investments compared to rebuilding or replacing engines later. Every million-mile car analyzed followed this principle. Fix it before it breaks, maintain it according to the manual, and respect the engineering that went into it. By combining informed vehicle selection with disciplined preventive care, it's possible to own and operate a vehicle for decades without major mechanical failures. The lessons from these automotive immortals apply not only to classic cars, but also to modern vehicles that continue to prioritize durability. For anyone passionate about longevity and reliability, the path is clear. Choose wisely, maintain proactively, and treat your car as an engineered masterpiece designed to last a lifetime. Following these principles, the next generation of million-mile vehicles is not a fantasy, it's achievable today.